We will finish up matrices today by looking at the last page of your matrices notes, and then we will go back to exercise 3.4, question number 10, and then after that we get you to try a 10-year series question. Okay, don't worry, I'll provide that question for you. Okay, so if you're not already at page 7 of your notes, you should be at page 7 now. Okay, we want to finish off matrices by just looking at a few special matrices and to look at the properties of matrix multiplication. Okay, the first type of special matrices we want to look at are your identity matrices. Okay, you have come across this before. Alright, now matrices, first of all, matrices of order n times n. That means that they have the same number of rows, same number of columns. These are called, if you recall, square matrices. Alright, and square matrices which has one on the main diagonal from the top left to the bottom right. Okay, for instance, if you look over here, okay, this matrix here, okay, on the diagonal is all 1. This matrix on the diagonal also all 1, and both matrices are square. We call these the identity matrix. Okay, and generally we will use the letter I to denote an identity matrix of order n. Okay, how do we know that it's order n times n? We write IN. So in this case, for instance, this identity matrix here, we will name it as I2. Okay, understood that it's a 2 by 2 identity matrix, and this matrix here, okay, we will denote it as I3. Now, some properties of matrix multiplication. Okay, first of all, let's look at the property related to identity matrix. Now, your identity matrix I is like your 1, okay, in your multiplication. Now, when you multiply anything by 1, you get back the original again. So, similar to that, when you multiply any matrix by the identity matrix, okay, no matter whether you put the identity matrix in front or at the back, you will always just get back the matrix itself. So for instance, I have a matrix here, alright, 1, 2, 3, 4. When I multiply it by the identity matrix, I will still get back the same matrix, right? This is the property of the identity matrix. Remember, the identity matrix is just like a 1. Okay? How about if you multiply everything by a 0 matrix? Right? When you multiply everything by a 0 matrix, you get 0. Okay, so in this case here, if we do the proper multiplication, we find that everything, okay, results in 0. And of course, the last part, whenever we do matrix multiplication, always remember, we write down the order. Alright, we check that the middle corresponds, and the final order, okay, we will take the first and the last, okay, you end up with a matrix of order m times p. Okay, so with this, it provides a good summary for matrix multiplication. Alright, if you need to revise matrix multiplication, you can go back and look at the earlier lesson. Okay, and please recall, in general, AB is not equals to BA. Okay, if you don't remember, just remember this. For instance, if I have a matrix, okay, 1, 2, remember this is a 1 by 2 matrix. Alright, because it has 1 row and 2 columns. Alright, times 3, 4, which is a 2 by 1 matrix. This is not equals to 3, 4 times 1, 2. Why? Because if you look at the right hand side, okay, the right hand side, this is a 2 by 1 matrix. This is a 1 by 2. Okay, now on the left hand side, you will end up with a 1 by 1 matrix. Whereas on the right hand side, you will end up with a 2 by 2 matrix. So you find that the matrices that you end up with, the order, okay, will not be the same. So they cannot be equal. So please recall, the order of the matrix is very important. We learned that before in AMAT, so please don't confuse this. And finally, okay, where you put the matrix is important. Okay, the brackets are okay. Okay, it doesn't matter where you put the brackets. So if you have 3 matrices A times B times C, Doesn't matter whether you multiply A and B first or you multiply B and C first. Okay, both are the same. So with this as a summary, we will now look at your exercise 3.4 question 10. Alright, please try the question first and then view the video to check your answers.